Thursday, 16th February 2017, the Congress Milan Polymer Days took place at Palazzo Greppi in Milan. It was a two-day international event organized by the University of Milan and the Italian National Research Council, Institute of Macromolecular Science, which focused on the up-to-date advances of various aspects of polymer science and technology. 5 plenary lecturers and more than 20 invited speakers came from the international polymer science community, presented their research results, and discussed future targets. The Congress was chaired by Elisabetta Ranucci and Marco Ortensi.
Today I had the pleasure on the Milan Polymer Days to be having the opportunity to talk about the possible applications of 3D printing for medical applications. During the speech I have introduced to the audience various types of polymers that can be used for 3D printing, and those polymers include polymers from natural origin like collagen and gelatin, but also some synthetic polymers like polyesters, which are nowadays already used as biodegradable sutures. In the second part of the talk, I have been giving an overview of different 3D printing techniques which can be used for printing 3D structures. And in each of those approaches, you start from a polymer solution or a polymer melt, and by a layer-by-layer deposition, you actually produce in the end a so-called patient-specific implant, which hopefully within 5 or 10 years from now can be applied in a clinical setting.
Today I presented some highlights about my work on polyvinyl alcohol reinforced Nano Cellulose for 3D printing application. My work is focused on production and characterization of the material, and in this project I develop some high improvement filaments for 3D printing component, and then I print with this filament some tensile sample for mechanical testing and thermal testing. Nanocellulose enhance the mechanical and thermal properties of this material, as we have seen from static and dynamic mechanical test, but we see that also improve the thermal properties, as we have seen from thermal characterization like DSC and thermogravimetric analysis.
I have the occasion to present an experimental work in this conference concerning the development of novel multifunctional polymer nanocomposites for industrial application. This work was financed by Caritor Foundation and through the support of ENSTN consortiums. We work in collaboration with the UFI Innovation Center, that is an important factory that works in the province of Trento, and we try to develop a novel multifunctional filter in which we add conductive nanofiller in order to heat them through the application of a voltage, in order to exploit the heating through the Joule effect, in order to render the gasoline more fluid and facilitating the starting operation.
Our work is essentially focused on porous polymers. Polymers with high porosity, especially nanoporosity, are useful for environmental reasons as well as for energy, for example for trapping methane, CO2, hydrogen. So we are focusing on the properties of those materials, and we are trying to obtain the surface area as high as possible, and so we can thus trap in those materials very high amounts of gases, and aims are the transportation, storage, gas filtering, and release of gases of high purity.
I'm working on the, let's say, reaction and resistance to fire of materials. It means that I'm fighting fire. And I gave a talk here at Milan Polymer Days about the flame retardancy of polymers. Well, I described the new flame retardants and how to make fire-safe polymers.
My works is basically involved in cyclodextrin nanosponges preparation and application. Cyclodextrin are natural starch derivatives and that can form inclusion compounds with a lot of active molecules, in particular drugs, and have actually a lot of application. Their properties can be improved when a cross-linking reaction is performed, and nanosponges are hyper-cross-linked polymer that show improved performance in comparison with the parent cyclodextrin. In particular, cyclodextrin nanosponges can be used as wastewater removal, as an innovative drug delivery system, as support for enzyme-like catalysis.
I'm expert and skilled in functionalization of polymers, and this kind of methodologies are important to improve some properties of starting polymers or to impart completely new features to the same polymers. For example, it is possible with this kind of methodologies to impart new photophysical properties, like in the case of light-responsive grafted functionalities, or to improve mechanical and thermal properties of the same polymers.
I center my work in the preparation and application on bioactive nanoparticles in a biomimetic way to the nature, that the nature teaches us, and we intend to prepare nanoparticles of very low toxicity and very high activity for cancer, for the treatment of tumors, of different kinds of tumors. We have discovered that there is a specific activity of the nanoparticles that are very well prepared and in a very easily way, based on on polymeric derivative of vitamin E. Vitamin E is one of the most active compound, not only as antioxidant for our cells, but also for the treatment of cancer. And we use this compound and derivative of this compound using a polymeric scenario for the treatment of breast cancer or other kind of cancer.
My work that was focused on the synthesis and the characterization of hybrid materials, biocompatible and biodegradable with polycaprolactone and graphene oxide, that is able to recruit cancer cells in vivo, and it's able to kill them in situ without explantation. So it could be used to avoid recidivism and of course tumor burden and decrease the invasivity of very invasive tumors such as breast cancer.
My topic is actually preventing things from burn. So I'm working on flame retardancy of materials, foams, textile, by different approaches. So one is the surface modification of fabrics and foams by means of water-based technique. And the water-based technique we're using is a layer by layer assembly, where you actually assemble a nanostructured coating on the surface of the fabric of the foam. And after this treatment, the fabric or the foam will not be able to burn anymore. So you apply a flame in order to start a fire, but the flame will extinguish and the fire will not propagate. Another approach for doing that is to use a nanocellulose based material. It is another topic I'm working with. We take nanocellulose out of wood, which is a nanoparticle hidden inside the structure of wood, and this can be used for the preparation of materials such as foams or thin films with strong mechanical properties.